Right, so let's look at another hypothesis test. CNN Money reports that the mean cost of a speeding ticket, including court fees, was $150 in 2002. A local police department claims that this amount has increased. To test their claim, they collect data from a simple random sample of 160 drivers who have been fined for speeding in the last year and find that they have paid a mean of $154 per ticket. Assuming that the population standard deviation is $17.54, is there sufficient evidence to support the police department's claim that the alpha equals 0.01 significance level? All right, so we're going to do the phantoms process. I'm going to go ahead and put those letters down the side. Okay, and then the letter P is the one that tells us kind of what we're doing. It's our roadmap for this. So we're being asked to see if we have evidence to support the police department's claim. So their claim is the amount has increased, and by that they mean the mean cost of the speeding ticket. So mean cost speeding ticket increased from $150. Okay, so remember, it doesn't have to be a complete sentence. You can kind of shortcut words a little bit, but you want to do that so that when you get to the end, you can just write your conclusion and move on, rather than trying to reread this paragraph and figure out exactly what to write. Right, we have two hypotheses, a null and an alternative. So you always want to indicate which is which. And we are testing a claim about the population mean, so we're using mu for both of these. The null is always mu equals, so we'll put our equal sign down. And the claim from CNN is that it's $150. So we'll put 150, and both of these use the same number. So always have the same number in your hypotheses. And we're looking at whether the cost has increased from $150, so it's more than, which makes this a right tail test. Okay, so remember, if you just think about the distribution, it's always centered at the null. Okay, and then which would be mu is 150, and if we're looking for greater than, we'd be over here. This would be the greater than 150. So that's where we get that idea that it's a right tail test. Okay, we have three assumptions or conditions to check. So simple random sample, normal large, and then if we know sigma. Okay, so they do tell us we have a random sample, so we can check that off. That's what allows us to do our statistical inference and apply our results to our larger population. Our sample size here is, let's see, 160. So n is 160, that's awesome. Definitely bigger than 30, so that condition allows the central limit theorem to kick in. And then sigma is, they tell us the population standard deviation is 17.54. So we've got that one as well. So and that tells us that we're going to do a Z as in zebra test. So we're using a Z distribution. Okay, we do have one, let's see, two other numbers on here. Let's see, X bar is 154, so I'm just going to go ahead and write that down. And then my alpha is 0.01. Right, so N, the name of what we're doing, that's the one mean Z test. Okay, and then I need to do my test statistic. So Z is equal to, this is X bar minus mu, sigma over root n. So I get 154 minus 150, 17.54 divided by the square root of 160. Okay, and I'm going to use Excel to do that. You can certainly use a calculator or Excel. I prefer to use Excel because I'll also be able to get my p-value right away if I do that. So I'm going to switch over to that program really quick here. Okay, so here is Excel. So notice we're down here on this Chapter 17 tab for the Z test. So my X bar is 154. I'll put that in. My mu, that comes from my null hypothesis, is 150. Sigma is 17.54, and the sample size is 160. Okay, so write down your test statistic on your paper. That's 2.88. You should always use at least 2 decimal places for that. And then our p-value. So remember that when we wrote our alternative hypothesis, we said that was a right tail test. Okay, so we'll take the greater than right tail value. So that's 0.001. It's always a good idea to write down, I would say, like 3 decimal places or so. 3 or 4 for the p-value is always a good idea. All right, so I have everything I need from Excel, and so I'm ready to go back to the paper and finish writing my conclusion. All right, so p is equal to 0.001, and I need to compare that to my alpha. So my alpha is 0.01. Okay, so this is 1/100th. This is 1/1000th. So this one is smaller. So p is smaller. And if p is smaller, my decision, so M is make a decision, do reject the null. So do reject H naught. And then we're ready to write our conclusion here. So we're going to need to use this step, and step P in writing our conclusion. So those are the 3 that we're going to combine together. So with a p-value of 0.001 at the, you can write either 0.01 or 1% significance level. Okay, so that we got all that from here. We do have sufficient evidence. Okay, and that 2 matches here. So if this had been do not reject, then we would say we do not have sufficient evidence. So this matches here. And then the last line here is going to be up here from the P of phantoms. So we do have sufficient evidence that the mean cost of speeding tickets has increased from $150. All right, so there you have that. And come back, we'll do another hypothesis test.